Science Journal for Kids and Teens presents How Can We Predict Extreme Winter Weather? Read by Miranda Wilson. Abstract. Some winter days are so cold and snowy that you feel like you are living at the North Pole. But what causes the weather to be so cold? Freezing temperatures and heavy snow at lower latitudes often follow a weak polar vortex. A polar vortex is a band of strong winds that traps a large mass of cold air above the North and South poles. When the polar vortex weakens, extreme cold air moves away from the poles. We wanted to work out what factors cause a weak Arctic polar vortex event. We found that warmer ocean temperatures cause air pressure changes. This change in air pressure causes a shift in the polar vortex in the upper atmosphere. Our results can help predict weak polar vortex events in winter. Predicting these events will improve the ability to forecast extreme cold and snow. Introduction. Predicting the weather is a challenging task. That's because there are many factors that can cause weather patterns to change. Sometimes what happens in the stratosphere affects the weather patterns in the troposphere. For example, a polar vortex in the stratosphere above the North and South poles affects the weather in the troposphere of the middle latitudes. A polar vortex is a band of strong winds that traps a large mass of cold air. The polar vortex affects the location of the polar jet stream. A jet stream is a narrow band of strong winds in the upper part of the troposphere. The polar jet stream is the boundary between the cold air at the poles and the warmer air at mid-latitude. The polar vortex above the North Pole is known as the Arctic polar vortex. The polar vortex is strong when there is lower air pressure over the Arctic and higher air pressure in the North Pacific and Atlantic Oceans. A strong polar vortex allows the polar jet stream to shift northward. It also has fewer curves. A smoother northern polar jet stream causes cold air to stay at the pole. That means the mid-latitudes experience weather that is milder than usual. But sometimes there is higher pressure over the Arctic and lower air pressure over the northern Pacific and Atlantic Ocean. This change in air pressure causes the polar vortex to become weak. A weak polar vortex could move off the pole, or even split into two. This change causes the stratosphere to warm. It also causes the polar jet stream to become wavy. That means warm air moves toward the pole while very cold air moves into the mid-latitudes. We wanted to figure out what causes a weak Arctic polar vortex. We hypothesized that there are events on the surface that cause the stratosphere to warm. Knowing what these events are will help improve weather predictions. In this image, you can see the layers of the atmosphere. On the left side of the infographic is the distance above the Earth's surface in miles, and along the right side is the same information in kilometers. Each of the layers are labeled on the left. From the surface of the Earth, they are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. You can see weather balloons in the stratosphere, meteors in the mesosphere, and the aurora and space shuttle in the thermosphere. Methods. We analyzed 29 weak Arctic polar vortex events that occurred between 1979 and 2022. We divided them into two groups based on the type of weak polar vortex event. Group 1 showed movement of the polar vortex off the pole. Group 2 showed a polar vortex that split. Then we focused on Group 1 to work out what might cause a shift of the polar vortex. We analyzed the surface conditions in the troposphere and in the ocean before the weak polar vortex events in this group. Data included observations of air pressure, air temperatures, sea surface temperatures, and sea ice concentrations. We used a computer to find patterns in the data. Results. We found changes in surface pressure conditions in the 15 days leading up to events from Group 1. This happened for 65% of the events. During these events, there was low pressure over the northern Pacific Ocean and high pressure over Europe and Asia. We also found that before a Group 1 event, the northern Pacific Ocean was warmer. There was also a decrease in sea ice in the Barents-Kara seas in the Arctic. Here in Figure 1, you can see a 3-panel graphic. In the left panel, A, you can see a stable polar vortex causes a smooth jet stream. The blue arrows represent the strong jet stream, and the cold air of the Arctic is shaded blue and labeled. In the middle panel, B, you can see the change in ocean temperature in the 15 days leading up to the Group 1 polar vortex events. Red shades show water that is warmer than normal, while shades of blue show colder than normal water. In the right panel, C, you can see the impact of changes in ocean temperature on the polar vortex. As the polar vortex weakens, it results in the jet stream becoming wavy. Looking at the graphic, how did the temperature of the northern Pacific Ocean near Alaska change before a weak polar event occurred? Discussion. Changes in ocean temperatures and sea ice can cause weak polar vortex events. Warmer ocean temperatures and a decrease in sea ice change the air pressure. The air pressure becomes lower over the northern Pacific, but it becomes higher over North Europe and Asia. The pressure difference allows atmospheric waves to travel to the stratosphere. This disrupts the steady vortex, causing it to weaken and move off the pole. Weak polar vortex events cause the weather to become extremely cold and snowy. During the February 2025 event, temperatures were as low as -22 degrees Celsius and -39 degrees Celsius in some places. Our findings can improve the ability to predict these weak polar vortex events. The effects of Group 1 events on mid-latitude weather occur about 2 to 4 weeks after the event. That means predicting an event helps forecasters predict weather changes earlier. Knowing why ocean temperatures and sea ice change is also important. Causes could include human activities that cause the atmosphere to warm. A warmer atmosphere causes a warmer ocean and less sea ice. That means human activities can affect a number of weak polar vortex events. Conclusion. A weak polar vortex event can cause freezing temperatures and heavy snow. When these events occur, it is important to make sure you are safe. Stay inside whenever possible, especially during snowstorms. If you need to go outside, make sure to wear clothes that can protect you from the cold temperatures. This includes wearing layers of clothing. You should also wear gloves or mittens, a coat, and a hat. Plus, you'll want to make sure that your pets are wearing clothes that keep them warm if they need to be outside. Staying warm during a polar vortex event is important for everyone. Thank you for listening to this recording. This work has been adapted from the original peer-reviewed paper in the journal Geophysical Research Letters, published on April 24, 2024. Research conducted by Mustafa Hamouda, Alice Portal, and Claudia Pasquero from the Institute for Atmosphere and Environment at Goethe University Frankfurt in Germany, the Institute of Geography at the University of Bern in Switzerland, and the Department of Earth and Environmental Sciences at the University of Milan Bicocca in Italy, respectively. See the PDF for additional information. Please visit our website, sciencejournalforkids.org, for more free science teaching resources.
Hey everyone, we're a small nonprofit and all of our resources are free. So if you like what you see, please subscribe and share.